हेलो स्टूडेंट्स, वेलकम टू फिजिक्स पाठशाला। आज हम आपके लिए लाए धमाकेदार वीडियो। देखिए, ये हमारे पास दो क्वेश्चन है। वी आर गोइंग टू स्टडी न्यू टॉपिक दैट इज ऑन हीट करंट एंड कंडक्शन थ्रू सॉलिड। तो इन दैट वी हैव टू फाइंड आउट हीट करंट, what is the conductivity of the material. If two materials join, what is the conductivity and the net current flow in that combination. Materials can be joined in series, materials can be joined in parallel. तो हमारे पास दो क्वेश्चन है, बहुत सिंपल नेचर के क्वेश्चन है। लेट अस ट्राई। ये सॉल्व हो जा रहे हैं तो फिर हम ये वीडियो आप स्किप करके आगे जा सकते हैं। इफ वी आर अनेबल टू सॉल्व, इसका मतलब हमारे जो हम क्लास लेने जा रहे हैं वो आपके लिए यूजफुल है। उसको अच्छे तरह मतलब पेन और पेपर के साथ बैठे और इसको सॉल्व करें। लेट अस ट्राई। तो इफ इट इज सॉल्व यू कैन स्किप दिस वीडियो। सॉल्व नहीं हो पा रहा है तो वीडियो को आखिर तक देखने की कोशिश करें। And let us see what the question is. It's a very simple nature. क्वेश्चन ये बोल रहा है दो मटेरियल हमारे पास है, एक एल्युमिनियम है और कॉपर है, और दोनों का लेंथ इक्वल है 1 मीटर और दोनों के क्रॉस सेक्शनल एरिया जो है 1 सेंटीमीटर स्क्वायर। बोथ आर वेल्डेड एंड सो फाइंड हीट करंट। तो इसमें हीट करंट कितना जाएगा वो है फाइंड आउट। यहाँ पर कंडक्टिविटी दोनों का दिया है। एल्युमिनियम का कंडक्टिविटी दिया है 200 वाट पर मीटर पर डिग्री सेल्सियस और कॉपर का भी कंडक्टिविटी दिया 400 वाट पर मीटर पर डिग्री सेल्सियस। इनिशियल एंड टेम्परेचर इज 100 डिग्री सेल्सियस और फाइनल एंड टेम्परेचर इज 25 डिग्री सेल्सियस। ये हो गया सीरीज कॉम्बिनेशन में दोनों है, और यहाँ पर भी दोनों। यहाँ पैरेलल कॉम्बिनेशन है, दिस इज एल्युमिनियम दैट दिस इज कॉपर। तो वही बोल रहा है कि व्हाट विल बी द करंट फ्लो इन दिस केस एंड व्हाट करंट फ्लो इन दिस केस। करेक्ट? कैन ट्राई योरसेल्फ। नेक्स्ट क्वेश्चन इज टू रॉड्स आर वेल्डेड टुगेदर एज शोन। तो ये नेचुरली इट इज अ पैरेलल कॉम्बिनेशन। इसमें K1 दे दिया है 10 वाट पर मीटर पर केल्विन और K2 दिया है 20 वाट पर मीटर पर केल्विन। इसमें पूछ रहा है व्हाट टू फाइंड आउट। वी हैव टू फाइंड आउट थर्मल कंडक्टिविटी, दैट मींस K इक्विवेलेंट ही पूछ रहा है। तो K1 is given, K2 is given, what is the K equivalent, that conductivity of this combination. Option is 10, 20, 30 and 15. K1 10 है, K2 20 है। Correct? So we have to, if you are just try, then we will proceed. Solution will be in this case heat current is 1 watt and in this case heat current will be 4.5 watt. So now to find out heat current, here we have to use formula heat current. Current is equal to temperature difference by equivalent resistance. In this combination, series combination, we have to find out equivalent heat resistance, or in this parallel combination also we have to find out equivalent heat resistance. Then we can find out heat current. In another case, here equivalent conductivity will be, for parallel combination it is 1 by 2 of K1 plus K2. In that case, this answer will be, we can find it is 10 plus 20 by 2. It will be 15 watt per meter Kelvin. Answer will be this one. And in first case, answer will be 1 watt and another one will be 4.5 watt. We'll study today heat transfer. In that we'll cover how heat is transferring through solid, heat, through liquid and gas, and no media is involved. When heat is transferred through solid, it will be heat through conduction, and when it will transfer through liquid and gas, it will be through convection, and when no media is involved, it is radiation. In that conduction, there will be actual movement of the material, whereas there is no actual movement of material. In convection, there will be actual movement of material, and in conduction, there will be no actual movement of molecules or material or substance, whereas heat will be transferred through conduction from one point to another point through molecular collision. Now we'll study how heat is flowing through conduction. Suppose the material is there and there is a, as you know, heat can transfer from one place to another if there is a difference in temperature. Suppose the temperature T1 and T2, and if there is a difference in temperature. Due to this temperature, heat will start flowing from higher temperature to lower temperature. See? Now, molecule at higher temperatures is at its higher kinetic energy and vibrates at higher motion or higher velocity. Once it will collide with its neighbor molecule, it will impart some energy and it will transfer some energy and it will be given to the neighbor molecule. And in similar manner, all neighbor molecules should start giving its energy to the nearest one, and in this way heat energy will keep on transferring from end A. Suppose this end is A and this end is B, then it will keep on transferring from end A to end B through this method of conduction. Here there is no actual movement of any molecule, but now it is only during collision heats are being transferred from one molecule to another molecule. Now, once we compare this conduction or flow of heat, here we say how much heat is flowing. Suppose if the heat flown from point A to B is Q, then the rate of flow or Q by T is the heat current. Is the heat current, suppose H. Now H became Q by T. Once we will compare it with this phenomena with flow of electricity, we will find there is so many similarities. In electricity, we find there is a flow of charge, and the rate of flow of charge is the electric current I, and this flow of charge happens due to the potential difference or difference in potential, that is V1 minus V2 or delta E between 2 points. Suppose there is a potential V1 and another end it is V2. there is a potential difference delta V, we say it is V1 minus V2. This potential difference is causing the charge to flow through this conductor, and this rate of the flow of this charge Q by T is our conventional current. Here, if we say this current electric due to electricity, suppose I, here it is heat current H, or this is I, this is H. Now, this current could be possible. करंट को कौन ड्राइव किया, करंट को ड्राइव कर रहा है, दिस द पोटेंशियल डिफरेंस डेल्टा V इज द मेन ड्राइवर हु इज कॉजिंग दिस इलेक्ट्रिक करंट थ्रू a conductor, or we can say it is now making this charge to flow through this conductor. Using this Ohm's law, we know that this current or this voltage, we say delta V, or V is proportional to I, or V is equal to I into R. Here we got a Newton R. R is the resistance of the conductor. We say Re, that is delta V by I. That means potential difference by electric current. In similar way, we can say that there is a heat current. It could be possible, or who is driving this? It is the temperature difference. We can say heat current could be possible due to difference in temperature, and this H is proportional to delta T, or delta T is proportional to H, or delta T is equal to H into RH. Here RH is thermal resistance. This is thermal resistance of the material. Thermal resistance of the material. Now we got potential difference. Here we got temperature difference, that is higher potential temperature minus low temperature T1 minus T2, and this question delta T by H is our thermal resistance. Thermal resistance. It is similar to our electric resistance Re. This is temperature difference by heat current. Temperature difference by heat current. Again, we know resistance of a material is proportional to its length and inverse proportional to its cross-sectional area. Suppose there is a conductor whose length is L and cross-sectional area is A. We say this resistance is equal to some constant L by A, or this constant we say is resistivity of the conductor. This is resistivity of the conductor. One by rho, or inverse of resistivity, is conductivity. Conductivity. This indicates higher value of conductivity indicates it's a good conductor. 1 by rho is equal to sigma, or this sigma is the conductivity of the material. Here, when we compare same with our heat flow, we find that thermal resistance is proportional to again length and inversely proportional to 1 by A, and we can say that RH is some constant to L by A. This, okay, here we got, where we got L by sigma A. Here we got L K by A. Once we compare these two, suppose this is equation 1 and equation 2, in that we find that K in thermal property is equivalent to sigma of electrical property. Here sigma is electrical conductivity. Then K is our thermal conductivity. Conductivity. Kh is our thermal conductivity. Now, if here now we got this formula rho became how much? Now rho became L R by A. L R. L by R. L by R A. Correct? Here K became L by R H A. Let us remember this formula. R is equal to L by K and R is equal to L by sigma A. Okay. Now, this R is again related to V by I. Here RH is related to this V means potential difference PD. This is temperature difference by heat current. Here suppose 1, this is also let us write it is 1, this is 2, this is 2 for electrical. Then next is heat current H. Here I is equal to, we say it is potential difference by resistance. Here heat current is temperature difference by resistance. Now if materials are connected in series, we know for series combination, if two conductors are connected in series, the equivalent resistance becomes equivalent resistance R equivalent is equal to R1 plus R2. R1 plus R2. Here also in similar fashion, if two conductors are connected in series, suppose one resistance RH1, another is RH2, then RH equivalent will be RH1 plus RH2. For parallel combination, if two conductors are connected in parallel, Then in that case, here this scenario is like that. Suppose one resistance is there and another resistance so is there. Here suppose one resistance is there, another resistance is there. दोनों पैरेलल कनेक्शन है, यहाँ दोनों सीरीज कनेक्शन है और इसका इक्विवेलेंट मान लो एक रेजिस्टेंस है आर इक्विवेलेंट. दिस इज R1, दिस इज R2. ये हो गया R1, दिस इज R2 और इसका जो इक्विवेलेंट है सपोज इट इज R इक्विवेलेंट. हियर R इक्विवेलेंट इज R1 plus R2 for series. This is for series combination. This for parallel combination. Here we know R equivalent is equal to 1 by R1 plus 1 by R2. In similar manner, for parallel combination, if both are in parallel RH1, RH2, we find R equivalent is equal to RH equivalent is equal to. We have to find out here RH equivalent will be how much. In this case, it will be 1 by RH1 plus 1 by RH2. Okay, let us study how much current flows, heat current flows. Suppose temperature is T1, T2 and heat current flows is 8. That is, if time is T, then heat current is Q by T. This Q or amount of heat flow depends upon first is temperature difference, which is temperature difference, that is delta T. This depends upon time. This depends upon if cross sectional area is A, cross sectional area. Then amount of heat will flow will depend upon A. Then it will be inversely proportional to length. If length will be decreased, that means more heat will reach from this end to that end. Or if length is increased, that means less heat will, in that same time, less heat will reach from this end to the other end. That means it is inversely proportional to L, if this is length, and it is proportional and it is dependent upon the material. Amount of heat will flow will depend upon property of the material. Property of the material of the conductor. That means we say Q is equal to some constant, we say it is K times area T1 minus T2 times T by L. This K is the conductivity. K is conductivity of the material. Conductivity of the material. Correct. Now, once there is a temperature difference and two materials are connected in series. Here we say the heat will flow here will be same heat will be flown here. Now H1 will be H2 that it is H. Now if there is a difference of temperature between these points, suppose point A, point B, point C. Here conductivity is K1, here conductivity is K2. Cross-sectional area is A, F. Here cross-sectional area is A, cross-sectional area. Suppose this length is L1, this length is L2. Then RH1 is equal to 1 by K1 L1 by A. RH2 is equal to, you can say it is L1 by K1 A. A means area. RH2 is L2 by K2 A. These two we have to remember. Now, we have two resistance. The R equivalent will be R equivalent or B. If this is equivalent to one conductor material and its resistance is R equivalent, in that R equivalent will be R H1 plus R H2. We know R equivalent will be, suppose this is K equivalent and this length equivalent, area is of course same. Here R equivalent is equal to 1 by K equivalent into L equivalent by A. Here L equivalent is L1 plus L2. Then K equivalent is equal to L equivalent by R equivalent into A. This is equation 1, this is equation 2. Now we know what is R equivalent. R equivalent is RH1 plus RH2. RH2 is RH1 is how much? It is L1 by K1. Order which is there. So we can combine both. It is L1 by K1A plus L2 by K2A. So K equivalent now became how much? It is L equivalent L1 plus L2 all divided by L1 by K1 A plus L2 by K2 A. K2 A. Now it became R equivalent into A, R equivalent into A. Now it became L1 plus L2 divided by L1 K2 plus L2 K1 or divided by K1 A into K2 A into so this will be K1 K2 A into A cancelled. So finally the K equivalent became K equivalent became K1 K2 L1 plus L2 into K1 K2 all divided by L1 K2 plus L2 K1. तो इसको यहीं पर ही ऐसे रख सकते हैं इट इज L1 प्लस L2 बाई L1 बाई K1 प्लस L2 बाई K2। इसको ऐसे भी याद रख सकते हैं K इक्विवेलेंट विल बी L1 प्लस L2 बाई L1 बाई K1 प्लस L2 बाई K2। स्पेशल केसेस if L1 is equal to L2 is equal to L, in that case K equivalent is equal to here let us put here it becomes 2 by 1 by K1 plus 1 by K2। इसी को ही डायरेक्ट रखें और 1 by K equivalent 1 by K equivalent is equal to 1 by 2 1 by 2 1 by K1 plus 1 by K2। This is the final formula equation for series combination. This is for series combination. Okay. Now, if two materials are connected in parallel, then what will be their equivalent conductance? What will be their equivalent conductance? That means suppose two materials are there. So let us write here for series combination 1 by K equivalent is equal to 1 by 2 1 by K1 plus 1 by K2. This is the final one. Where L1 is equal to L2 is equal to L. Okay. Now here length is almost same. Here this is area 1, this is area 2, cross-sectional area. Suppose this is like this. Two materials are connected. They are welded here. They are welded here. Earlier it was welded here. center. Now total heat current, it will be through H1, this is through. Second one H2. तो ये टेम्परेचर T1 है, ये टेम्परेचर T2. Here current, total heat current H is equal to H1 plus H2. Total resistance, or you can say RH equivalent, is equal to 1 by RH equivalent equal to 1 by RH1 plus 1 by RH2. RH1 is the resistance of material 1, so this is material 1, this is material 2. RH1, as we know, is L by, so the length is same for all. Length K1, A1, RH2 is equal to length by K2, A2. This is our temperature difference T1 minus T2. This R equivalent is, again, RH equivalent is equal to, suppose this combination, it became equal to one body which it is K equivalent and total heat is H in that case, and total heat, thermal resistance will be RH equivalent. Then in that case we will find RH equivalent is equal to delta T by H, that is again equal to L equivalent by K equivalent, A equivalent. A equivalent is L by K equivalent into A equivalent is area A1 plus A2, A1 plus A2. Now we can find what is, this is equation 2, then this is equation 1. Now we can find out what is 1 by R, 1 by RH equivalent, or from this equation 2 we get K equivalent. K equivalent is equal to L by RH equivalent into A equivalent. A equivalent, this is L equivalent, L by RH equivalent is equal to 1 by RH1 plus 1 by RH2. That's okay. So this is 1 by RH equivalent to L by A1 plus A2. R by H equivalent is 1 by RH1 plus 1 by RH2 to L by A1 plus A2. Now this became 1 by RH1 is L by K1 A1 it is 1 by L by K1 A1 plus 1 by RH2 is L by K2A2. This is right? All into this L by A1 plus A2. Now, can find LL taken. This L will be next it is can say it is K1A1 plus K2A2 by L into L by A1 plus A2. A1 plus A2. Here thing is K1 L1 by L plus K2 L2 by L. This is L by A1 plus A2. If both area is same, then it will become K1A1 plus K2A2 by A1 plus A2. Here L, this is 1 by L is taken out, cancelled. The final value is now K equivalent became K1A1 plus K2A2 by A1 plus A2. This is the final value. And in special case, if A1 is equal to A2 is equal to A, in that case, K equivalent will be K H equivalent. K, okay, that is K equivalent only. K equivalent will be K1 plus K2 by 2 or 1 by 2. That means for parallel combination we got K equivalent is equal to 1 by 2 of K1 plus K2, where A1 is equal to A2 is equal to A. This is for parallel combination. करेक्ट? तो अभी हम लोग को पता चल गया टू मटेरियल जब पैरेलल कॉम्बिनेशन होगा व्हाट विल बी देयर इफेक्टिव कंडक्टेंस, और जब सीरीज में रहेगा व्हाट विल बी देयर इफेक्टिव कंडक्टेंस. तो इसको हम एक ऑब्जर्व कर सकते हैं, इट विल बी जस्ट इक्विवेलेंट टू combination of capacitance, इसमें एक रहेगा कि 1 by 2 is multiplied, 1 by 2 this term is multiplied. कैपेसिटेंस में वो नहीं रहता है. 1 by C equivalent becomes 1 by C1 plus 1 by C2, इसमें 1 by 2 multiply हो गया. And for parallel रखा है C equivalent to C1 plus C2, इसमें 1 by 2 multiply हो जाएगा. तो this 1 by 2 is multiplied, then that means combination competition with 1 by 2 term is multiplied to get K equivalent. Okay, with this we could cover what is what is heat current, what is conductance, what is heat current, and how much heat will flow. That also we have studied. Next class we will study what is how heat is transferring through convection and through radiation. Through radiation.